All right, I think we will make a start now. Good morning, good afternoon, good evening, greetings, and welcome to SIDS Talk Plastics. My name is Saeed Hamid, advisor to the Alliance of Small Island States. SIDS Talk Plastics is a series of webinars focused on the issues of concern to small island developing states in the negotiation of an international legally binding instrument on plastic pollution, including in the marine environment. This, the seventh episode of SIDS Talk Plastics, will focus on chemicals, polymers, and plastic products of concern. Now, we know the term of concern has been one that is highly debated in the course of the negotiations. There have been many adjectives and identifiers such as problematic, hazardous, harmful, avoidable, unnecessary. So we've empaneled a list of experts here today and speakers to discuss some of these issues. So without further ado, please allow me to introduce our speakers for today's session. Dr. Rolf Pyatt, Executive Secretariat for the BRS Secretariat, who's also joined by Ms. Kay Ono-Woodall from the BRS Secretariat as well. We have Dr. Sarah Dunlop, Head of the Plastics in Human Health at Minderoo Foundation and Professor at University of Western Australia. Thank you. Special thanks as well to Dr. Sarah for coming because it is 1 a.m. where you are right now, so we appreciate your participation today. And finally, we have Dr. Linroy Christian, Director of Analytical Services at the Laboratory of the Ministry of Agriculture, Antigua and Barbuda. So without further ado, I think we will start with our program today. First on the list, we have Dr. Rolf Pyatt, who will help us to contextualize the issue. So I will now hand the floor over to Dr. Pyatt in terms of contextualizing polymers and chemicals of concern in the plastic pollution issue. Please proceed.
Thank you very much, Said, and thank you for the invitation to address, of course, this very important meeting putting together the SIDS. As you know, and I'm sure you've mentioned before, plastic waste is a big issue. And as we speak now, there are 5 offshore plastic accumulation zones in the world oceans. And the biggest of them is located in the North Pacific Ocean and also known as the Great Pacific Garbage Patch. And it is estimated to cover a surface of 1.6 million square kilometers, which I'm sure for many of us islanders are much, much bigger than many of our islands put together. Now, the situation is much worse than this because we've started to observe, and I'm sure colleagues on the panel will confirm later on, increasing research of plastics, especially microplastics and their constituents in the human blood, in the human lungs. And of course, some emerging research shows that they are also entering into the brain. So the issue is very serious. And as you know, there's been an international negotiations started to negotiate an international treaty on plastics. And I know AOSIS and the SIDS have been really, really active. I think this series of talks and exchanges will help many small island states to understand the issues that is not just the plastic bags that you see around us, but the thousands of chemicals that are used in those different types of plastics for different uses, from the home to the clothing to specialized materials, which many of it end up into the ocean. So based on the latest studies, we have now identified more than 13,000 chemicals associated with plastics and plastic production. So it's quite a large amount of chemicals. And as mentioned before, the chemicals of concern have been found in plastics across a wide range of sectors and products and value chains, including toys, children's products, packaging, electrical and electronic equipment, vehicles, and of course, products that we're in contact with in our daily lives, which means that us as SIDS need to take this matter quite seriously. And of course, I know we've been active on the climate change front, but I think we need to also ramp up our engagement within the chemicals and waste space, because some of these issues, we can see the impacts already now on the ground and in many of the regions of the world. Now, the Stockholm Convention on Persistent Organic Pollutants provides an effective mechanism for assessing the characteristics of some of these chemicals, as well as a pathway to closing the production and use of those most dangerous ones. And I'm very happy that many of our SIDS are party to the Stockholm Convention, and they engage in a similar manner. And of course, when we go downstream, we have the Basel Convention, which sets standards for the management of plastic waste and rules on their trade. And for those of you not familiar with the Basel Convention, we will be happy to organize extra webinars so that we can explain and go into some depth of how the Basel Convention can support you in the sound management of plastic waste. And we really don't have time at this session here to go into depth into what the Basel Convention does. And of course, many of the SIDS across the world are now party to the Basel Convention as well. And we extend support through Basel Regional Center in the Caribbean, which is based in Trinidad and Tobago, and the Regional Center in Samoa, which is based on the spread. So if you're not sure and you don't have access to the information, we'll be very happy to provide you with information on how to engage and work with our two main conventions with respect to plastic, which is the Stockholm Convention and the Basel Convention. We also have another convention, which is the Rotterdam Convention, but I don't think we have time today to go into this. And before ending, I wish to highlight the upcoming SIDS International meeting, which will be in Antigua and Barbuda. I hope I got the place right now. And the next week in New York, we will have the first preparatory meeting for this international conference. In my view, having attended all the past 3 conferences that have been organized with regards to SIDS, it is very important that we do put the issue of chemicals and waste on the agenda. For so long, yes, we've been focused on climate change, we've focused on resilience, we've focused on vulnerability, and somehow at the cost of our health and at the cost of the quality of environment, we seem to have not given enough attention to the issue of chemicals and waste, and in this particular case, plastic waste. So with those few words, I wish you the best of luck and looking forward to listen to the panel and also to hear questions and comments from you all. Thank you. And once again, my appreciation to the organizing team for organizing this series of exchanges and webinars. Thank you very much.
Thank you, Dr. Payet. And I think we also special thanks as well for extending that extra support to do more deep dives into how they can be in complementarity, perhaps even with like the existing conventions under the BRS. We will certainly take you up on the offer for perhaps additional webinars to dive more deeply into those issues. Thank you. And on that note, we will now switch gears a little bit to Dr. Sarah Dunlop, and we will discuss here understanding polymers of concern and their potential impacts. And I think this is a good segue because one of the questions I see in the Q&A is polymer a chemical? And if not, what is it? So perhaps this is a good segue into Dr. Sarah's Dunlop's presentation. Thank you.
Thank you, Saeed, and thank you everyone for all the work that you do in this space. The plastic pollution and all the health impacts are of utmost urgency, and it's wonderful and very encouraging to see the work that the small island states and others are doing. So I want to start by emphasizing that overwhelming as it is as a waste issue at the end of its life cycle, plastic is also a health issue across the entire life cycle, depressing as that is. So plastic is, of course, fossil fuel derived, and so this is a story about chemicals. They're invisible, but just because they're out of sight does not mean they should be out of mind. And plastic needs to be considered, the question in the chat, as a very complex, compounded chemical mixture. So polymers, yes, they are a chemical, and they form the backbone of the plastic product, the plastic material, but they're absolutely useless on their own. They'd fall to bits. So what you need to do is use one or many of the 13,000 existing chemicals to give them this extraordinary range of properties and give us this equally extraordinary range of plastic products that we use in our everyday life. So what I want to do is take you through the harms to human health across the plastic life cycle and start right at the beginning and talking about making the plastic polymers and the petrochemicals that we need, all those additives. This process is very energy intensive. You have to split open large molecules that exist in coal, oil, and gas, the fossil fuels, to make it into smaller compounds, smaller molecules, which you then build up again into the polymers and the plastics additives. And about 90% of the fossil fuel stock is actually used to provide that energy. So we see that deaths and disease occur as a result of the burning of fossil fuel from particulate matter, air pollution, as well as the chemical pollution that comes from burning fossil fuels. Plastic is also a carbon emitter, and it's equivalent to about 3 to 4% of greenhouse gas emissions. And the health impacts on humans from climate change, of course, are extensive. We need to consider heat exhaustion and lethal humidity, sea level rise, and impacts on agriculture that really all add up to the social cost of carbon. The actual extraction of fossil fuels, for example, fracking, is highly chemically intensive and water intensive, uses an awful lot of water, which people would otherwise drink. And the polymer production at ethylene cracking and petrochemical plants uses multiple chemicals to actually make these polymers and monomers rather than additives. So the sorts of chemicals we're talking about at the production stage are solvents such as benzene, toluene, which are both known carcinogens, heavy metals, volatile organic compounds, formaldehyde, radionuclides, just to name a few. And the health effects we see at this early stage include respiratory and cardiovascular disease, effects on the skin and eyes, premature birth, low birth weight, and malignancies in workers, particularly in fence-line communities. So moving on to the use of the chemicals during everyday life, I described how the polymer is embedded with lots of chemical additives. Those chemical additives are not chemically bonded to the polymer and they leach out, they escape. And they get into the environment and they get into us through air, food, water, packaging, paint, materials, fabrics, you name it. And a wide variety of chemicals are actually found in human blood, urine, and also solid tissue samples. But considering just 3 chemicals, and we've looked at these very carefully, bisphenol A, phthalates, and flame retardants, we can see consistent evidence for harm. If you look at the primary literature, it's quite inconsistent, but what we've done is to look at a review, a systematic review of all the systematic reviews, and that has been submitted for publication. And for those 3 chemicals alone, we see consistent evidence of harm for miscarriage and decreased birth weight at around the time of birth, IQ loss, hypertension, and obesity in children, as well as cardiovascular disease, type 2 diabetes, endometriosis, and polycystic ovarian syndrome in adults. And moving on to the disposal, and it really is disposable because recycling doesn't work very well, only about 10% is recycled, but we see a lot of uncontrolled burning and uncontrolled landfill, as well as controlled municipal burning and landfill. And the problem here is most acute in small island states, disadvantaged fence line communities and waste pickers. You know, these communities did not develop, they did not create, they did not make or generate the plastic in the first place, but they are bearing the brunt of its impacts. And again, during disposal phase, we see a wide range of toxic chemicals, including polychlorinated dioxins. I mean, think Agent Orange, which they're highly carcinogenic. And we see cardiovascular disease, heavy metal poisoning, cancers, neuropathy, and lung disease. So I've just taken you through the life cycle, and I want to take a deeper dive and describe some work led by Dr. Bidita Siwu in our team to really drill down into the health impacts of plastics through the polymer lens. And we're going to look at 4 high production polymers of concern: polycarbonate, polystyrene, polyvinyl chloride, and polybutadiene. And I'm going to follow the same life cycle approach that I've just given you. And we're going to look at the chemicals in those polymers. So it's chemicals, 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 again and again and again. So polycarbonates are one of the most widely used plastics. It's in fact poly brackets bisphenol A close brackets carbonate. And BPA is the monomer. It's not an additive, it's a monomer used to make the polycarbonate. It's got extraordinary properties, thermal resistance, mechanical properties. It's durable, highly optical, transparency, and it's all sorts of commodities: engineering, construction, automotive, aircraft, data storage, you name it, electrical, telecommunications. But during its production, very toxic chemicals are used. Phosgene, that's mustard gas, which was used in World War I, and methylene chloride, both are carcinogens. And you get leaks in the chemical facilities and the BPA leaks as well. BPA leaks out of products, and that includes the polymer resins around tin cans. And it's a strong endocrine disruptor, and it's linked with type 2 diabetes, polycystic ovary syndrome, obesity, and cardiovascular disease, as I mentioned above. And in fact, BPA is deemed so toxic by the European Food and Safety Authority that they've reduced the tolerable daily intake from 4 nanograms per kilogram body weight to just 0.02 nanograms per kilogram body weight. That's almost below the limits of detection for the mass spectrometry techniques that we need to use, and that's a 200-fold drop. So you also find BPA in landfills. Moving on to the second polymer, polystyrene, that has both short and long-lived applications, as you can imagine, like packaging for your takeaway food, food containers, as well as insulation and electronic casings. The styrene monomer itself is a carcinogen, and it's listed on the Stockholm Convention SIN list, substitute it now list, and it migrates into food and hot liquids and released into the air when foam is cut. And as with most plastics, because it's made from fossil fuel, it's likely to burst into flames because it's a fossil fuel, and therefore you need flame retardants. And we know that they are linked with type 2 diabetes and the PBDEs, the polybrominated diphenyl ethers with IQ loss, quite serious impacts. I mean, that's changing what it is to be human, and it's affecting children. Reduced birth weight, gestational diabetes. Blowing agents are also used to expand the polystyrene, CFCs, and we know that they are ozone depleting. We also know a lot about polystyrene microbeads, widely used in personal care products, although bans are beginning to come in place. And during disposal, it's the usual suite of chemicals, flame retardants, sulfur and nitrogen dioxide, carbon monoxide, that actually leak during landfilling and open burning. And it's also an extremely hard plastic to recycle because of the very high volume to weight ratio, and most facilities won't actually take it. So the last polymer of concern the second last is polyvinyl chloride, which can be rigid or plasticized. And the production of the monomer itself, vinyl chloride, involves mercury, and we know how toxic that is, PFAS, chlorine gas, ethylene chloride, another carcinogen, and other chlorinated compounds. Vinyl chloride is also highly toxic. Just think of the rail accident in Ohio, United States, where carriages of the stuff spilt during an accident and were set on fire. And we see respiratory issues as well as angiosarcoma of the liver. Polyvinyl chloride has phthalate plasticizers in it in large quantities, and think of medical appliances, for example, in the ICU unit and the neonatal intensive care unit as well. And you're getting a heavy dose of phthalates at probably the last time in your life that you actually need it, when you're seriously ill. There are also stabilizers in PVC, and BPA is used in PVC as an antioxidant. And of course, during disposal, there's the usual suite of flame retardants, plasticizers, metals, and particularly in e-waste. The last polymer I want to consider is polybutadiene. It's a form of synthetic rubber. It's used in tires, footwear, and sporting equipment, for example, golf balls, cores, conveyor belts, and cable insulation. And the butadiene monomer is a known carcinogen, and it's actually one of the top air pollution-related health risk drivers in the USA. The chemicals that are used in polymerization is the same story, titanium tetrachloride, and during vulcanization, which is a hardening of the polybutadiene, benzene and hydrazine, and also UV stabilizers. That's really important because you've got to stop the tires from busting open and degrading as a result of UV exposure. So you put UV stabilizers in there, but they're all highly toxic. Tires in landfill result in leachates going out into groundwater. And then, of course, you get the burning of scrap tires, which releases particulate matter, sulfur dioxide, and the polychlorinated dioxins again, and metals. I've covered off on the chemicals, and there's a lot of intense interest in the particles. the micro nanoplastic pieces, smaller and smaller pieces itself. And when you think about it, the destiny of every single piece of plastic on this planet is to go on breaking up into smaller and smaller pieces and micro nanoplastics. But in contrast to plastic chemicals, it's a very controversial area. And although we're beginning to learn that microplastics are in us, we know very little about the health impacts. One of the problems is contamination in samples and also our actual ability to detect those particles and know that it's plastic, know the chemical composition, and be absolutely sure that you are looking at a plastic particle and not a signal as a result of contamination from the biological matrix that you're looking in. So there's a lot of work to do in that space. Nevertheless, the evidence that we've got, the best evidence we've got, is from textile workers who are inhaling plastic particles from the air, and there we see a litany of interstitial lung disease. That's an umbrella term used to describe a large group of diseases that cause scarring of the lung. And it's really the only direct evidence we have at the moment for harm to human health. There's quite a lot of lab-based studies, but it's often used, the doses are much higher than a seen in normal environmental conditions. And also it's mostly experiments on polystyrene of a known size, and it's clean and it's spherical. Naturally occurring micro nanoplastics are going to be much more varied. So thinking about the criteria, however, I should just say, just because we don't know about the health impacts in humans does not mean to say we should not be concerned. We should be extremely concerned, and we need to act fast. With respect,
Dr. Dunlop, just real quick, before we get into the criteria discussion, I think maybe we can make a pause and get into some of the questions, and then we can have the conversation contribute that way. Also, as well, if there are any resources from Mindaru's and that kind of discusses some of this work as well, please feel free to send them in the chat. But we can get into the question, because I think the first question coming up is on criteria, and I think we can have a discussion there on how we identify some of these materials and products. So I think we can get into the general panel discussion now with the others. And the first question that is posed is, what are some examples of criteria under existing conventions or instruments used to identify these materials and polymers, chemicals of concern? And how would you view their applicability within the context of the future plastic pollution instrument? There's also an added question as to how we should approach identifying these materials under the instrument. So to start off this conversation, I will hand over to Ms. Kay.
Yes, thank you very much for the opportunity to address this question from the perspective of the BRS Secretariat. Firstly, it's essential to acknowledge that several existing conventions provide valuable insights into the identification of substances of concern. The Stockholm Convention, which primarily focuses on persistent organic pollutants, is one such example. And this convention employs two sets of criteria when reviewing new chemicals proposed for listing. The first set focuses on the risk profile of the chemical, including persistence, bioaccumulation, toxicity, and potential for long-range environmental transport. Then the scientific subsidiary body, the POPs Review Committee, determines whether the chemical is likely, as a result of its long-range environmental transport, to lead to significant adverse human health under environmental effects, such that global action is warranted. And this is a very important statement, because this is what the committee really look into the data to come to a conclusion that whether the chemical meets POPs criteria or not. Then the second set of criteria involves socioeconomic considerations, including the efficacy and efficiency of control measures, availability of alternatives, positive and negative social impact, and waste implications. So following these evaluations, the committee recommends listings to the governing body, the Conference of Parties, for consideration. And these criteria can serve as a valuable starting point for a plastic pollution instrument. However, it's crucial to recognize the unique characteristics of polymers and chemicals associated with plastic pollution, as just described by Sarah, which may require a tailored approach, because polymeric substances exhibit diverse chemical and physical properties, posing challenges in identification. And an effective process should integrate criteria addressing the entire life cycle of plastic products, which could include consideration for polymer structure, additives, and potential transformation products, throughout manufacturing, usage, and disposal stages. So the 10 groups of chemicals linked to plastics have been identified in the recent UNEP report. I will put this in the chat due to toxicity and potential for release. There are certain flame retardants, UV stabilizers, PFAS, phthalates, bisphenols, alkyl phenols, and alkyl phenol ethoxylates, biocides, metals, metalloids, PAHs, and dioxins and furans, like non-intentional chemicals, just like described by Sarah, and many of them are actually persistent organic pollutants meeting criteria. However, phthalates, bisphenols, alkyl phenols, alkyl phenol ethoxylates, they are all organic chemicals, but they're not as persistent as POPs, like in environment. So in applying these criteria to the new instrument, it is essential to adapt and expand upon them to address the unique challenges posed by plastic pollution and ensure a comprehensive and effective approach to identify and manage polymers and chemicals of concern in the context of the instrument's objectives. So this should also be mindful of potential implications for chemicals that might overlap with existing instruments, like flame retardants, the brominated flame retardants, or dioxins and furans just mentioned. They are all already listed under the Stockholm Convention. Thanks.
Thank you, Kay. I think that was an excellent application of what exists, but also being cognizant of what might be unique to the plastics issues that still needs to be addressed in developing criteria. Building on that, I wonder now if Dr. Christian would like to offer some insights.
Hi, thank you very much. And certainly thank you to the previous speakers for setting the scene for this. And I think it is important, again, to recognize the usefulness of what has already been established under the Stockholm Convention, for instance. And it's important in, I think, looking at this issue of assessing hazards, because again, as Kay would have stated, the issue of long-range transport may not be the most relevant within this particular agreement, but certainly the potential hazards and looking at it at different stages. And within island states that are, many are not within the production side of things, but perhaps on the disposal end, or when you're repurposing plastics from an occupational health standpoint. Certain companies, for instance, are into extruding plastics and making new products from plastics, and therefore some of these health concerns may still be applicable, and therefore the chemicals and their transformation products, it is important for us to ensure that we address this issue and assess, again, alternatives. And because the convention, will also look at this issue of alternatives. And also one important lesson to learn from Stockholm is this issue of regrettable substitutions that we have to certainly avoid. And therefore, these criteria that have been established under Stockholm provides a very good basis. And there are other bodies, perhaps within WHO, joint expert committees that we have between WHO and FAO, like JECFA, that also are used to establishing criteria for assessing impacts to human health. And within our region, the Cartagena Convention, which is geared towards the protection of the marine environment within the wider Caribbean region, there are constructs within this to assess potential hazards, particularly to the marine environment. And these ad hoc working groups are established to assess what may be potential negative impacts to the marine environment. And therefore, these expert groups and the types of assessments that need to be done, I think we can build a lot and learn, of course, not to duplicate efforts, but there's a whole suite of information that we can take into the new agreement that would allow us to move things forward quite a bit as it relates to identifying and potentially banning chemicals of concern. Thanks.
Thank you. On that note, Dr. Dunlop, I know we were getting into a little bit of the criteria before and how to identify. Did you want to offer any thoughts on this particular question?
Well, yes, we would like to make the point that to think the criteria to protect health, we also need to think about the product itself as well as the chemicals. Obviously, we've talked about the chemicals, but for the application, these are in multiple consumer goods, so we're going to have need some wide-ranging policies there. Also, plastics are produced in extreme volumes, so we've got to be able to cope with that. And one of the fascinating things is the material properties of the plastic itself may result in hazards that a chemical might not have on its own. So the plastic particles and large, big bits of plastic, micro and nanoplastics, will be acting as rafts to carry those chemicals long distances into the environment, across international borders, enable them to be persistent when perhaps they wouldn't have been otherwise, and also potentially bioaccumulative. And of course, all of those are criteria for getting listed on the Stockholm Convention. So with respect to the chemical composition, I think we've just got to recognize in this treaty that plastic is a complex chemical mixture. It really is absolutely staggering, and that has to be taken into account, hard as that is. And that means there's a huge diversity of chemicals and complex co-exposures that we really don't know anything about. And one of the answers, I think, is have an instrument that considers full disclosure and transparency about the chemicals that are in plastic, and that would go a very long way. At the moment, we're flying totally blind. We've no idea what's in, we know what's in pharmaceuticals and food, and the things we deliberately put in our mouths. But with respect to chemically laden plastic, food packaging, which is lacing in contaminating our food and drink and the such like, we've no idea. We know what's in the biscuits, we don't know what's in the packet. And then I think this has already been mentioned by Liv Roy, and that is we've got to minimize the risk of regrettable substitution. It happens again and again and again. We had the PCBs as flame retardants, then the PBDEs, and now the OPEs, and they're all turning out to be just as toxic as each other. BPA is another absolute classic one. That's been banned. It says BPA free on the product, but it doesn't tell you it's now BPS and BPF and BPZ and BPAF and BPP. So this is just not good enough. We've got to have that transparency. So those are the points that I'd like to add for criteria.
Thank you, Dr. Dunlop. Secondly, historically, what have been some of the main challenges for small island developing states in achieving their obligations through established criteria and standards on their existing chemicals conventions? This question I'll pose first to Lynn Roy with a follow-up from Kay in terms of how other conventions might have designed concessions to support implementation and transition. So we'll start with Dr. Christian and then Kay.
Yes. As it relates to the overall challenges, I think one overarching issue is that not seeing the relevance of this issue. And at a very high level, yes, there's a lot of information put out there in the public sphere that this problem does exist. But within our various constituencies, there's a wide range of, is this really a problem for us? And if there isn't that recognition at the highest level within government, and I'm speaking of someone who works within government as well, you tend not to get the prescribed action within the timing that you may need, or also to contribute at this particular stage of the negotiations into shaping a negotiation that will benefit us at the end of the day. So in further down the line, I mean, when we accede to such negotiations, to such treaties, we are now putting ourselves in a position to not be, totally compliant with the obligations, because we may not have established or seek to establish in a timely manner the institutional arrangements required. And if we don't have that mindset to look at the necessary arrangements, the legislative aspects, and we've looked at this through several different projects. And if I would say to you now, we're now within the Jeff Islands project, and we're still looking at comprehensive legislation to address chemicals. And there have been so many of these projects that have come along, and we still seemingly haven't gotten the message that we need to treat this as a primary issue. The use of standards in this case is a bit, it's something that we need to be clear about, and using, criteria versus standards. It's not to get too technical on that point, but standards are obligatory. Not obligatory, sorry, they're voluntary. And therefore, what we have to ensure is that when we initiate discussions and to establish very firm criteria, we're doing so with science as the background. And we ensure that the recognition of the science and bringing the science to the fore, as it were, is what we're using as the basis for these negotiations. It would mean then, therefore, that the development of science and the contribution of science to the negotiations from our developing states is extremely important. Our scientists bringing information, there is sometimes local and traditional knowledge that we have seen being discussed within the negotiations so far that are deemed to be very important, and we need to bring that perspective forward. And when we're looking at, again, establishing how we assess these chemicals and products when they're on the market, to develop our capacity to monitor and to address the health concerns by providing the necessary scientific information to do so. So our capacity to bring the science to benefit our populations, it's extremely important as well. And one more word on standards is that our regional construct, for instance, the CARICOM Regional Body for Standards and Quality, CROSSQ, at some point, this well-established infrastructure needs to be engaged for us to ensure that we bring the best regional perspective forward as it relates to standard setting. Because at some point, the countries that do manufacture have to do so based on standards at minimum, if not converting these standards into technical regulations and law that we have to be bound by. So incorporating this perspective, this well-established perspective, is extremely, extremely important. Thank you.
Thank you, Dr. Christian. I think you emphasized a really good point there when it comes to the constellation of actors and who might have a work relevant to how we kind of deconstruct or address the design of solutions for this issue. Ms. Kate, please go ahead.
Yes, so your question related to the concessions that are provided to support transition by developing countries. One notable example is the financial and technical assistance provided to developing countries, like the Stockholm Convention, for instance, like Jocelyn Roy mentioned, has established a global environment facility to provide financial resources for capacity building and the implementation of national action plans. This has been crucial in supporting developing countries in establishing monitoring systems, regulatory frameworks, and infrastructure for managing hazardous chemicals. Another example is the provision of exemptions, either with or without time limits, for certain applications that lack readily available alternatives or require transition time for phase out. So this concession is not exclusive to supporting transitions in developing countries, but is relevant to any party. So looking ahead to a future agreement on plastic pollution, similar concessions could be important. Developing countries often face challenges due to limited resources and expertise in managing plastic substances. So future concessions should prioritize capacity building initiatives, technology transfer, and financial help to ensure an effective and equitable transition. And also, I would like to mention establishing platforms for knowledge sharing and collaboration among countries, institutions, and industry stakeholders can also enhance the effectiveness because this collaborative approach fosters a collective understanding of challenges and solutions, and it will promote more inclusive and cooperative framework.
Thank you so much. Recognizing that science continues to evolve and advance, what mechanisms would you recommend to allow for any such changes under a global plastic pollution instrument, and what experiences could be drawn from existing chemicals conventions? And I know we kind of touched on those two already, but Kay, within the context of BRS, what mechanisms helps to feed into the implementation of the conventions?
Right, so drawing from the experience from Stockholm Convention or other existing conventions, Regular systematic reviews stand out a critical mechanism. These reviews involve a comprehensive assessment of emerging scientific evidence and technological developments, like the review by the POPs Review Committee is one example, by establishing a dedicated scientific advisory body similar to those found in existing conventions. May be possible to ensure a continuous and informed evaluation of new findings relevant to plastic pollution. In the case of Stockholm Convention, the nomination of new chemical is led by a party. It has to come from a country. But we also recognize that there's a discussion among science policy panel, and more academic body-led processes could also be an option. And such an advisory body could offer recommendations for adjustment to the instrument based on the latest scientific insights. Another element is flexibility. Flexibility within the regulatory framework is very important. The instrument could consider incorporating mechanisms allowing for expedited updates in response to urgent scientific developments. And this flexibility will avoid cumbersome amendment processes and ensures that the regulatory framework remains agile and effective in addressing emerging challenges. An example from the Stockholm Convention is the ability to add new chemicals to the list of regulated substances through amendments to its annexes rather than the convention text itself, providing a template for adapting to evolving scientific understanding. But very important point raised by Sarah about regrettable substitution. Indeed, when it comes to including in the scope of the convention, it is always very important to make sure that what is replaced with a regulated chemical is not cause another new yet very serious concern for future. So consideration on safer alternatives also would be very important aspect. Thank you.
Thank you, Kay. And on that note, Dr. Dunlop, would you like to offer some insights there on the scientific mechanism that could help with implementation?
Yes, thank you. Thank you. So it's true to say that as plastic chemicals have proliferated, regulation has totally struggled to keep up with the quantity of the new chemicals and the complexity. I mean, it's just mind-blowing. And any approach, as Lynroy very eloquently said, has to be driven by science with a really robust science policy interface. That's where our information comes from. And it has to be thoroughly embedded and be able to give fast, pragmatic and precautionary restrictions where they're needed. I've mentioned the importance of transparency, but there's two other things I'd like to briefly mention. And one is to really get our heads around reversing the burden of proof. We need independent from the petrochemical, producers, independent, non-industry-led evidence on toxicity testing, and get that done really properly around whether it's carcinogenic, reproductive toxicity, endocrine disruption, bioaccumulation, you name it. And the other thing we need, so that's the pre-market testing to reverse the burden of proof. But that is done in animals. So the other thing we need is routine post-market biosurveillance in humans. We can't deliberately test chemicals in humans. We have to rely on those labs tests, but they're largely unsuitable because they're short-term. They don't mimic human lifespan, nor the complex and chronic diseases that we experience. So at the moment, we have to wait and rely on ad hoc investigator-led actually, and taxpayer-funded epidemiological studies to find out if there are any harms. And it's a long haul. It really, really is. But there's nothing formal in place. The closest we've got is NHANES in the United States, the National Health and Nutrition Examination Survey, and then HBM4 EU, as in human biomonitoring in the EU. We ought to have a lot more of this. And it wouldn't be just for plastic chemicals, it'd be for industrial chemicals, 350,000 of those. And we're just flying blind. We're just doing this massive uncontrolled experiment on the planet.
Thank you, Sarah. I think that really helps to add some gravity to the problem and how much we don't know and how much we should be considering in advance of INC4 and how we help to flesh out some of these details. We're going to switch gears just a little bit because one third arm of the discussion today was on plastic products of concern. And we know that during the course of the negotiations, there might have been some synergies with how we look at chemicals and polymers and products, especially products that contain those chemicals and polymers that are concerning. On that note, in switching gears to there, we know that Antigua and Barbuda have made some strides in the Caribbean as it relates to plastic products and regulations. Linroy, would you be able to provide any insights there and within the treaty context of the treaty and drawing from your experiences? How do you view the regulation of plastic products of concern, adequate transitionary periods, and what could be potential applications?
Yeah, sure. Absolutely. I mean, as you stated in 2017, 2018, Antigua and Barbuda took the measure to restrict the importation of single-use plastic bags, 2017. 2018, this was expanded to styrofoam products. And though I think these measures were quite commendable, and there was a certain amount of consultation that happened, I think a lot of the information and action that took place after that went in place, some of it would have been quite beneficial to happen prior to that ban. Now, as was alluded to earlier with the issue of alternatives, with plastic products, these alternatives that we have been flooded with since those bans, we have very little information as to how effective these products actually are. We're still grappling with the issue of you still have waste to dispose of. So you have a new material that has sometimes a wider range of substances that are unclassified. The traceability of it is actually quite questionable because you can't then step through the line of manufacture to determine what a certificate of analysis would look like or what a certificate of composition would look like, because it's very hard, because these components, there are a wide range of components that are considered to be these alternatives. And therefore, what is the impact of these alternatives on human health? That is still yet to be determined. And there are so many products that have come through Antigua and Barbuda since 2017. And again, it's still a waste management issue. If your waste management is not going to be developed enough to address issues of uncontrolled burning or not particularly environmentally robust management practices, environmentally sound management practices, you are ending up again with the same issue of exposing humans to potentially harmful chemicals, but in a different form. So the issue of alternatives is still quite relevant with respect to products. And though I am for very strict criteria within the convention to identify what is required, I think the issues for a country that is a net importer and not a producer, how do you effectively manage these products is a huge question. And it's really reliant upon us having a treaty where the countries that do produce have to recognize that they have a great obligation to ensure, and we as small island states have to ensure that the treaty has this, that those stipulations are in fact quite robust and would again facilitate our understanding as to where we go with respect to alternatives. There's the economic side. Most alternatives are more expensive than the frontline plastic products. And therefore, from an economic standpoint, and you've seen it in the negotiations already, that is a sticking point where some countries are saying that when we're looking at these stringent measures, we're in fact putting or imposing upon certain countries a high economic burden. Now, there is no real study to say what is the burden on losing a human life to cancer for use of products, but we know business as usual is not something that we should do. And we must have enough information, again, science-based information on these alternatives to the plastic products that we are seeking to restrict. And certainly, it is, again, something we could have benefited from, but we have taken these measures and now we have to sort of catch up and to ensure that the products that we are utilizing as alternatives are in fact as safe as possible to humans and also to the environment. And that is a marker for us to also improve upon our waste management systems. Thanks.
Thanks, Dr. Christian. And I think what I'm gathering from everyone's input so far is that we might need a part 2 to this webinar, but on top of that, like there's so many other issues to unpack in examining this. Like we have to look at the importance of transparency, which everyone has spoken to, flexibility for different economic contexts, the importance of the science policy interface, and not looking at these issues in a vacuum, but cross-sectorally as it relates to scientific mechanisms, the development of alternatives and substitutes, and critically, capacity building and financial support to small island states for implementation. On that note, I think we might only have time for one final question of each of our panelists. We'll give you roughly 60 seconds each, hopefully, and then we could do maybe a quick question from the audience. The final question would be, there is arguably a lot of information as well as existing established practices and potential relevant bodies and organs dealing with these substances and products. How can the instrument best promote complementarity and coordination with existing conventions and instruments to identify and regulate the materials containing some of these chemicals and polymers? And how can this help inform the INC process right now? In terms of that question, we will start first with Dr. Dunlop.
Well, thank you. That's quite a question. There's lots to unpack there. I mean, I think what we're seeing in the INC process is a splitting of countries according to whether they're high ambition or not, whether they are like-minded countries equals the petrochemical producing states who in INC3 put a lot of effort into getting their representatives on the ground, and procedural delays and the such like, and complete absence of any, therefore, intercessional work. I mean, that is an absolute travesty. So I think we've got a lot of vested interest in this process. We've somehow got to get around that. With respect to the specifics of coordinating with the different conventions, there are people on this panel who are far more expert than I, but I think there's a lot that we can learn from BRS, you know, what they've got and what we need for these whole suite of chemicals, and rather than reinventing the wheel. I do note, though, that it does take a very long time to get a chemical regulated, so we've got to think about that too. I mean, it's decades sometimes to get something on the Stockholm Convention. Decades. We haven't got that time. We just haven't. So I think we've got to cut the problem off at the source. There are 13,000 chemicals used in plastics. We only need about 150 different functions. Why do we need 13,000 different chemicals? Again, it's vested interests and proprietary information making more money. Profit over people.
Thank you, Dr. Dunlop, and thank you once again for making the time. I know it's quite early in Australia right now. Kate, would you like to continue the discussion?
Right, thank you very much. So plastics is very complex products and at the same time very useful for our everyday life and very critical applications, including for medical purposes. And chemicals are essential part to provide necessary functionality. And that is also one of the reasons why there are so many variety of chemicals involved in plastics. But it's always very crucial to think about how to manage risks, how to understand risks. And here it's what the question also includes how to promote complementarity and coordination with existing mechanisms. It is definitely very important to have each of the stakeholders, government, industry, civil society, and academia, to have a good understanding on what's there in the existing mechanism and what can be complementary in the plastic pollution, and share information on the chemicals in products and articles. I think with the Stockholm Convention, indeed, we have added 16 new chemicals since the convention has entered into force. And thus, this is the mechanism that has provided the consideration, and with the cooperation with the industry and academia, civil society. But here we are talking about even more complex issue with the plastic products, not just only chemicals that are concerned. So I would think that the even more of the coordination among different stakeholders would be necessary, and this negotiation at INC is a starting point to bring these different perspectives together. And I think that it's also very important to include another other platform like Science Policy Panel to have more effective coordination, not just only what is already existing, but what's under negotiation by UNEP. Thanks.
Thank you, Kay. I think that was an excellent suggestion there on your wrapping. Dr. Christian, some final thoughts?
Yes, I mean, I can't say I agree more with my previous speakers as to what is essential to this. And we've seen already in the negotiation process some aspects that I think are quite unfortunate. Now, the issue is that it has to be science-based, and it would be naive for me to think that it will be completely science-based. So what we have to do at least is to utilize or find a way to raise the level at which we recognize what is already in existence by recognized bodies. If I were to criticize the process in a way, is that the role of BRS, and I don't want to be the cheerleader here for BRS, but the role of the BRS and other key intergovernmental agencies being observers to the process, I think it's not helpful. I think the contribution by these agencies will have to be improved, particularly if we're not going to have, again, as Sarah mentioned before, not having this intersessional process. How are we going to move the process along? And then we're going to say, well, we only have this amount of time to reach an agreement. So if we're going to handicap the agreement, then we cannot have it within the time frame in which it was determined, and whose interests are we actually serving in all of this. So I would strongly recommend, of course, that the established agencies, bodies, and the science behind this is given a higher profile. And therefore, we have the ASPAR Convention, a lot of work being done on marine plastic litter, microplastics. We have Cartagena as well, where this is a land-based source of pollution protocol, which is for the Caribbean Sea, the wider Caribbean region. A lot of information is there, BRS, lots of information, but we have to clean the process up so that, as was mentioned before by Sarah, that it can't take 10 years to monitor and then to evaluate and then to list. Then the countries who are producing these chemicals, then there has to be a stringent enough agreement, a strong enough obligation that these countries cannot introduce such chemicals without the proper review process. How will these chemicals make it into the market if they're not properly evaluated for the purpose in which they've been intended? So it means that industry, as we all know, as I would like to say, the tail is wagging the dog, as it were. And therefore, we have to ensure that those countries, there must be some justification as to why these chemicals are utilized in their market, or they have been utilized for us to be exposed to without the requisite information being available to us to make an informed decision as well. So the tightening, there's a lot of narrative around small island developing states developing regulatory mechanisms to do X, Y, and Z. I would hasten to add that it is some of the developed countries that require massive improvements in their regulatory system, and also their waste management system. If everybody controls their garbage, none of it enters into the sea. I'll just put it that quite frankly. So we have to ensure that all countries obligations are fully, and that we ensure that these perspectives are brought forward in the text of the convention that we want to put in place. Thank you.
Thank you, Dr. Christian. I don't know if Dr. Pyatt is still on call. I don't know if you wanted to add anything really quickly. Doesn't seem like it, but then otherwise, Thank you all for taking the time. Oh,
Yes, I'm there. I'm just looking for the button to click. So I just wanted to say thank you very much, Hamid, for organizing this. And like I said in my introduction, I want to go deeper and further with colleagues on this. I think it's a very important issue for small island developing states. So let's continue that conversation. And we are very much open in really explaining to colleagues. Especially from the side of the Basel or the Stockholm Convention. And also we've done a lot of work in the linkages between the existing conventions and the upcoming international treaty. And we do support the secretariat of this international treaty in so many ways so that they can also do their work. So just want to reiterate that. And of course, right now on my agenda and my radar is the SIDS international meeting, the fourth one. And I'm really, really, trying to encourage SIDS to really come up with some very concrete text and resolution within the area of waste and chemicals management. Thank you very much.
thank you, Dr. Payet. On that note, we will conclude today's session. A recording of this episode will be on the AOSIS SIDS Talk Plastics playlist. But we will circulate to all the attendees afterwards. Thank you all for making the time to attend and have a great remainder of your day, or rest rather.
All right.
Thank you.
Thank you.
Thank you very much. Bye.
Great to meet everybody. Wonderful discussion.
Thank you.